Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the final part on inequalities. This is solving quadratic inequalities. Before watching this video, make sure you've seen the previous three, and also you should only watch this video if you're doing higher tier. Okay, the past two videos, this one and the previous video, are for higher tier only. So if you are doing foundation, you can ignore this video. You will also need to make sure that you're really happy with factorising quadratics in general before starting this video. So if you're not, go back and check out the videos we have on that first. So our first question is solve x squared plus 7x plus 12 is less than 0. So the same as if you looked at the video for solving linear inequalities, we basically treated it as if it was just a normal equation and solved it how you normally would, then dealt with the inequality at the end. We're going to do the same here. So if you'd like to write it with the equal sign instead, if that makes it easier to just visualize, that's fine. I'm just going to keep it as the inequality because it doesn't really make any difference so far. And the way that we solve quadratics, obviously we've normally got multiple ways to do it, but the main way is factorising, isn't it? We want to put it into two brackets, okay? We want to put it into double brackets. If you want a recap on how to factorise quadratics, I'm going to link the video now, okay, for factorising quadratics. So I'm just going to whiz through it because obviously today the focus is not the factorising, the focus is the inequality part. So if you want to double check factorising, then feel free to do that as well. So I'm just going to do the two brackets and obviously just copy the same inequality symbol. Because it's x squared, it's just 1x squared, I know it's going to be x and x. Then I look at my symbols. We're multiplying to make a positive, and we're also adding to make a positive. So everything is positive, isn't it? So I'm going to put plus and plus. Then I just need to know, okay, which two factors of 12, when I add them together, make 7? So if you want to, obviously you can list them all out, but this one I feel like is pretty obvious being that they're all pluses. It's quite easy, isn't it? So 3 and 4 obviously would add up to make 7. Doesn't really matter which way around you put them. Okay, we factorised it. Now we need to solve it, okay? We need to go, what is x? Because it's a quadratic, we always get two values, don't we, pretty much? So I'm going to whiz through the solving, again, separately to inequalities, just so that you can understand where it comes from if you don't already know this. But some of you will already know that you just basically change the symbol, don't you, of these two numbers. But I'll just explain why. So for now, I'm going to put equals to 0, just so that we can do it that way. So I've got x plus 4. Obviously, that's multiply, isn't it? X plus 3 equals 0. If you just think about it in terms of numbers, if I multiply two numbers together, the answer is 0. Well, how do I get 0? One of those two numbers originally has to also be 0, doesn't it? If not, maybe both of them. You can't multiply two numbers together and get 0 if you don't have any of those numbers being 0 themselves, right? So what we're saying here is these brackets just represent a number, don't they? One of these two brackets must be 0 itself. If not, maybe both of them. And because we don't have any context, we don't know which of these two brackets might be 0, we don't know if it was both of them, so it's kind of like if, write down the first bracket, obviously you don't need the literal brackets now, but write down that if the first one is equal to 0, do you see how now this is a linear equation? It's much easier to solve, isn't it? Because linear equations, we just need to get x equals. So in this case, we need to move the 4 across. And to move the 4 across, we have to subtract it, don't we? That's the opposite calculation. So if it is the first bracket that is equal to 0, then x must be minus 4. And then you go, or, because we don't know, if the other bracket is equal to 0 and do the same thing, in this case, we just need to subtract 3, don't we, from both sides? X is minus 3. That's just solving, isn't it? Again, that's not really to do with inequalities, that's just solving. So I know my two values of x are minus 4 and minus 3. What I now need to do is put it back into an inequality though, okay? This is the bit that a lot of people struggle with. You should be able to do the factorising absolutely fine and the solving fine, which would get you most of the marks, okay? So even if you just get this far, you've got the majority of the marks, which is great. So definitely write down this much, even if you're not sure where to go after that. But now we need to know how to put it back into an inequality. And it's not just the same as copying what they've got here. So for example, if I just went, oh yeah, I'll just chuck back in that inequality. Well, it doesn't really make sense because you can't really have it being less than minus 4 and less than minus 3. They don't both work at the same time, do they? So don't do that, okay? There are two ways that you can figure out the answer. Either you just memorize, if the symbol is facing towards the 0, it means this answer. If the symbol is facing towards the quadratic, it means the other answer. You can just memorize it. Or the way I do it is I kind of figure it out with a graph. Okay, so I'm going to show you both options, and then you just figure out which is better. Do you prefer to memorize, or do you prefer to use the graph method to visually figure it out? So I'm going to call it obviously the quadratic. If the inequality symbol is facing towards the 0, obviously the inequality faces towards the greater value, doesn't it? If it's facing towards the 0, that means your answer will be a range. So what you need to do is put, for example, here. So let me write it. Answer is a range. You might want to just memorize this. So in this case, for example, you'd have obviously -4 is a smaller number, x in the middle, and -3 is the bigger number. We're saying x is within -4 and -3. It's a range, isn't it? Okay, so that's answer option 1. Obviously that's then for this one, isn't it? But if your quadratic, which we will see another example of next, has the inequality symbol facing towards it rather than the 0, your answer has to be 2 separate inequalities. Okay? I'll show you, for example, let's say if it were to be these values, we need x to be smaller than the smallest value, so x is less than -4, and x is greater than -3, which is the bigger value. So if you want to go based off of memorization, I can write that, memorization, yeah, if I can spell, that would be great. This is what you need to memorize. If the inequality symbol is facing the 0, I create a range. Obviously, the smaller value at the left and the bigger value at the right, and x in the middle. If the inequality symbol is facing my quadratic, which is the x squared bit, then I need 2 separate inequalities. The x has to be smaller than the smallest number, right? So smaller than -4 in this case. And you also then write down x is bigger than the bigger value, okay? If you want to memorize these 2 options, that's great. For quadratic inequalities, these are the only 2 possible options. You either get a range or you'll get 2 separate inequalities, okay? So at least you know what you're aiming for. The other thing is if you get to the exam, like you're literally in your exam, you factorized it, you've solved it, and then you're like, gosh, I can't remember. Just guess. To be honest, it's better to write down something than nothing, okay? Obviously, I'm not saying do that now, considering you've still got a lot of time in the year. But if you're literally sat in your exam, if it's a mock, if it's your real GCSE, it's better to write down something, even if you're not sure if it's right, than nothing. It's better. You've got a 50-50 chance, haven't you? It's not bad odds, okay? So either you can memorize this, right? So take a screenshot of this if you want. Obviously, you know, the numbers will change depending on the question. Or I'll show you the other way, which is not memorization. It's just more figuring it out, you know, what makes sense. So I'll kind of go through and explain that. If you're happy then with memorization, you go, do you know what, that's easy, I'm just going to memorize it. Fine, ignore what I'm about to say, okay? So this will also kind of give you an explanation as to why those 2 things are. Some people in maths, they go, do you know what, just tell me what it is. I don't really need to know the deeper reason why. I just need to remember that that's what it is. Absolutely fine, okay? But if you're interested in knowing why that works, this is the reason. So the way that I like to do it, because I don't really trust my own memory, to be honest, that's the only reason, is that I figure out. So imagine that this is a graph, right? We all know a quadratic graph, we should know by now, is normally a U shape. Obviously, if it's negative quadratic, it's going to be upside down, but that doesn't matter really. That's not really going to make much difference, okay? It's basically a U shape. So our quadratic would be written as a graph, x squared plus 7x plus 12, and we know that y is normally on the other side, isn't it? Y is here. So what I'm saying is, I'm going to sketch my graph. You're not going to get marks for this, right? But I just sketch it really roughly for my own use. It doesn't have to look good at all. It doesn't have to look accurate or to scale, nothing. I've got -3 and -4, so let's just say that's -4 and that's -3. I know this is not to scale, it doesn't matter, as I said. I know it's positive, so I know it's going to be a U shape, so it's something like this. Can you see, if I get the highlighter, that the 0 that we have here is where the y is, isn't it? Okay? The left side of the inequality is the same, which is the line, effectively. The right side of the inequality is where the y would be as a graph is 0. So what we're saying is where y equals 0, because they've replaced the y with a 0, which is the x-axis, isn't it? Y is 0 is the x-axis. So that's that line there. And now we're saying, you think about the inequality, so y, which is this here, y and x, y is always like vertical, isn't it? Up and down, vertical. So we're thinking vertically, okay? What we're saying is if you think about the quadratic as the line, so I'm going to write it over here, the line, Ignore the literal x squared plus 7x plus 12. That doesn't mean a lot to you, does it? Think about it as the line. And then 0 is where y is 0, is the x-axis. We're referring to this part here, okay? What we're saying is, are we referring to the part of the line that is above 0 or greater than 0? Or are we referring to the part of the line that is below 0 or less than 0? Okay, and that's where I go, well, in this example, my inequality is facing the 0. The 0 is the bigger value, so my line, or the part of the line that I'm looking for, is less than 0, i.e. less than or below this line here. So of my curve, I'm referring to this section. Okay? And you see how if you then go back, okay, well the x-axis is this, horizontal bit here. My x values is therefore anything between -4 and -3. So therefore I know it's a range. Now to some people that's just going to be way too complicated and not make any sense. That's fine. Just use the memorization method. Just go, do you know what? I'm going to memorize. If the inequality symbol faces the 0, it means a range. If it faces the line, the x squared, it means two separate ones. Absolutely fine. Okay? But to some people, this might just click. It might just make sense. So in this case, I know it's a range because I've said, oh, my part of the line that I'm referring to is below where y is 0, below the x-axis. And in terms of x, that is between -4 and -3, isn't it? So I'll show you the other option. Obviously, if I just undo this now quickly, let's say the symbol is facing what I call the line, i.e. the quadratic, and it's not facing the 0. It's saying to me, I'm saying which part of the line am I referring to? Is it the part that is greater than 0, i.e. above the x-axis, or is it below? Well, yeah, if it's facing towards the line, well, I'm referring to the parts of my line that are above 0, i.e. above where y is 0. So it's these two. Do you see how they're two separate I call them like tails. They're two separate tails, aren't they? Which is why we get the two separate inequalities. And if you think about the x values, so all of the part of this line on the left, the x value is anything less than -4, isn't it? It's going to the left. I mean, obviously to infinity, because technically that goes up forever, doesn't it? So therefore I know, okay, x is anything less than -4. And on the other side, it's also, on this part, on the right-hand side, this part of the line, the tail, is x in terms of anything bigger than -3, isn't it? But they're two separate things. They can't be arranged, can they? You can see on the graph they're not connected. They're not together. Okay, so it's anything greater than -3 or anything smaller than -4. So that's how I use the graph, okay? I know that sounds long, but obviously once you've, if this really makes sense to you, the graph way to figure it out, you just literally sketch it. You might even just not even need to sketch it. You might be able to imagine it in your head and go, right, oh yeah, it's this part of the line, which means it's a range, or it's this part of the line, which means two separate ones. So those are your two options, okay? I want to make this really clear. Those are your two options. So you either use the memorization method where you go, I'm just going to memorize. If the inequality symbol faces this way, it means this. If it faces the other way, it means that. Or I'm going to go, do you know what? I feel like, yeah, the graph bit makes sense in my head. Like I said, you don't really need to sketch it like this. It doesn't have to be a nice sketch or anything. But I know if I can visualize that we're referring to the part of the line that, the two separate tails, then I know it's two separate inequalities, or it's a bit in the middle underneath the y equals 0 line. Then it's a range. Okay, so it's up to you. But in this question, we are referring to this part, aren't we? Just so you know the answer to this particular question, because we're referring to the part of the line that is below 0, therefore x is between -3 and -4, okay? It's the range. So this is your actual answer for this question, but obviously I was just showing you the two possible answers, okay? Okay, next question. So I'm going to go through and try and recap it in a shorter way. Step 1 is you're going to factorize, okay? So at this point, still nothing to do with inequalities. Factorize your quadratic. You need to be really confident with factorizing quadratics, not just because of any questions with factorizing quadratics, but also because of this type of inequality. There are so many topics where you need to factorize quadratics, okay? So make sure this is one of those skills that you are super secure with, especially in higher tier. So, okay, I'm going to whiz through that quickly. I know it's x squared, so x and x. I am multiplying to make a positive, but when I add them, it's negative. So I need two negative symbols. And then I'm saying factors of 20 that add together to make -9. Obviously, when they're both negative, well, that's pretty obvious, isn't it? It's going to be 4 and 5, but, you can technically list them if there's loads of options. List them out in order so you don't miss any. Obviously, it's going to be 4 and 5. Chuck those in. When I solve it, Obviously, I wrote out the full thing of, oh, well, if this bracket equals 0, then x is that. You can write that out if you want. However, you can just kind of make that leap and go, yeah, I know that x is going to be 4 and 5, isn't it? They're going to change symbols, okay? So you can skip that bit. They're not really looking into that part of it that much because we're looking at more so inequalities than we are solving quadratics, for example. And then step 3 is, okay, but I need to put this back into an inequality. So like I said, either you go, well, I've memorized the fact that my inequality symbol is facing the quadratic, therefore it has to be 2 separate inequalities, and you just do that and remember that x is smaller than the smallest number and bigger than the biggest number. Or like I did, you do the graph method, which I'm going to whiz through quickly. This is how fast I would do it. I'd be like, oh, okay, 4, 5, cool. Okay, if I imagine it this way, we said that obviously where y is equal to 0, is it greater than that or less than that? Is it above or below? This is the line. So the part of the line, which is, in this case, greater than 0, so above. So I'm referring to these 2 parts, aren't I? These 2 parts of the graph are above where y is equal to 0, obviously the x-axis. So therefore, in terms of x, it's anything here, isn't it? So anything where x is less than 4. And it could also be where x is anything greater than 5. So this is my answer. That's as quick as I do it. Literally, I mean, I wouldn't obviously even write out the line, and I wouldn't write out y equals 0, because obviously I already know that, but I'm just writing it down so you can, see the explanation. Your answer is the 2 separate inequalities, but remember, it has to be smaller than the smaller number and bigger than the bigger number, okay? Otherwise it would be a range, wouldn't it? That's literally it. Factorize it, get your 2 values of x, and then however you like, put it back into that inequality. Okay, feel free to try this one now if you feel like you've got, the general concept. Like I said before, if you're in the exam and not sure, at least be happy with, first of all, factorising and then solving. At least step 1 and step 2 you should be able to do anyway. The bit that then is tricky is the 3rd step, which is putting it back into an inequality, okay? So we should all be able to do the first 2 steps anyway and get the majority of the marks for those. So step 1, as I said, factorise. So I know it's just x squared, so I'm going to factorise it into 2 brackets, copy the same symbol. Okay, we're multiplying this time to make a negative, which means I know it has to be plus and minus. And when I add those 2 factors together, one being a positive, one being a negative, it makes positive 1, doesn't it? That's 1 overall. So thinking of factors of 56 where the difference is 1, 7 and 8. Okay, 7 and 8, however, which one has to be plus and which one has to be minus? Well, I need it to be a positive overall, so I need 8 as in the bigger number to be the positive and then minus 7. 8 take away 7 is positive 1, isn't it? Okay, then you solve it, so you go, oh yeah, x is just minus 8 and positive 7, and then step 3 is to put it back into the inequality. That's again where you just go, do I memorise the direction of the inequality sign, or do I use my graph? So I've got, what, minus 8 and then 7. Again, it doesn't have to look nice at all. I know it's a positive quadratic, so that's what it's going to look like, and then I go, okay, if I have my inequality, let's say, the line, and my inequality symbol is facing towards that. So I'm referring to the part of the line which is above or greater than where y is 0, isn't it? So it's above the y-axis. So again, I'm referring to the 2 tail ends, aren't I? So I know that x has to be smaller than minus 8 and x has to be bigger than 7. The only other thing with this one is because can you see that it's also equals to? It's, in that case, greater than or equals to. So just copy that for your answer as well. There's my answer. That's literally how fast it is. As long as you're really happy with quadratics and factorising, it can be that quick. Okay, so we've got the same thing again, but you might notice here that it's not laid out in the same way that we're used to. Again, it's not really related to inequalities. This can also happen with just quadratics in general. The way that we solve a quadratic is we need to have all of the terms on one side of the equation or the inequality and a 0 on the other, don't we? That's what we need. So in this case, we're doing the exact same thing. We've just got an additional step at the start. We need to rearrange this just to make sure we've got everything on one side. Now, a lot of people would think, oh, it's easier if I just move the x squared because that's only one term. I personally want to keep the x squared positive. Being on the left-hand side right now, it is positive, isn't it? So I'm going to move the 4x and the 96. It's not really that much work, is it? You're just subtracting both of them, okay? It's not a lot of work. You can move the x squared across by subtracting it, but then you'd have to multiply or divide everything by -1. to make the x squared positive, ideally. And if you've seen, obviously, when we did solving linear inequalities, solving inequalities is exactly the same as equations, except for the part if you end up multiplying or dividing by a negative, you have to flip the symbol. For me, that's just going to be too complicated. I prefer to not have to flip the symbol. So all I'm going to do is move the 4x and the 96 across. You're literally just minusing both of them as if, in a normal equation, you'd just do the opposite, wouldn't you? Which is subtract in this case. And then I don't have to flip the symbol. Okay, I'm just keeping my life a bit simpler. So I've got x squared minus 4x minus 96, same symbol, and then that's obviously 0. Now we're back to the same as we were before, aren't we? Now you can carry on. Step 1, factorise, and then step 2 is solve. Okay, so you might need to rearrange it. It's almost like a trick question, but don't be thrown by that. Just rearrange it, put it into the format that you are familiar with, then carry on. Okay, we know it's going to be two x's, x and x, and then we have multiply to make a negative, so plus and a minus. So factors of 96, that when I add them together, I get minus 4, obviously. Being a plus and a minus, the difference is minus 4, isn't it? Something I know 12 goes into 96, that goes in 8 times. Actually, yeah, that works, doesn't it? The difference between 12 and 8 is 4. Now, overall, when I add them, I need a minus 4, so I need 12 as the bigger number to be the negative. Plus 8, so 8, take away 12 is minus 4, isn't it? Okay, step 2, solve it. Well, I know that that's then going to make it minus 8 and positive 12, just change the symbols. And then we're back to step 3, which is to put it into the inequality. And this is the same thing again. You can either use the graph method, or you can just memorise what the format should be. Okay, it's up to you. So I just draw this really dodgy little sketch here and go, okay, so refer back to this one now, obviously. We don't want to look at this because that's not really helpful, is it? So I've got the line, which is the x squared bit, all of my quadratic, is less than or equal to 0. So I'm saying, which part of the line am I referring to? I need the part of the line that is less than 0, i.e. when, if you remember, we said where y is 0. So I need the part of the line that is, in this case, below where y is 0, which is this bit in the middle. Because that's in the middle, if you think about the x values, that's anything between minus 8 and 12, isn't it? X is between that, it's a range. The only last thing is I've also got this equal sign, so I'm going to write the equal sign too. That's it. There's your answer. So it has to be a range for this one, okay? Okay, so this one is absolutely fine as is. We don't need to rearrange anything. However, you might notice that we've got x squared and just minus 25. It looks like we're missing the middle bit, isn't it? Normally we have 3 terms for a quadratic. We have the x term in the middle. This one doesn't have it. That's still fine though. I've written here obviously difference of 2 squares. I always bring it up. If you've been through factorising quadratics, you'll have seen me mention it. If you've gone through the expanding, you'll see me mention it. The reason why I bring it up so much is because there's always one question on it. And even if it's just 2 marks, and I don't mean in terms of inequalities necessarily, but in general, there's always a question on it. And it's always a trick question because most people forget. And you look at this and you go, well, I can't put it into 2 brackets because it's not the full quadratic, but I can't put it into 1 bracket because there's nothing in common. And then you're stuck. No, yeah, we can actually factorise this into double brackets. We just need to recognise the format of the fact that we've got x squared, which is a square number, 25, which is a square number, and a minus. That is literally the difference of 2 squares, isn't it? 2 square numbers, and the difference is subtract. So you should already know this, that this will easily factorise. You just put x, and then you square root the square number there, which is 5, and then you just have to make sure that one is a plus and one's a minus. If you've seen the expanding video, you'll know that when you expand this, you still get the x term in the middle, but obviously it does cancel itself out. Effectively, it's 0x, okay? So that's why it's a plus and a minus. You cancel it out. Okay, so if you want to look into difference of 2 squares a bit more, check out that video, okay? We're not going to go into any detail today, but I just want to mention this because they could obviously put it in inequalities. And then from here, we're in the same place, aren't we? So that was factorised. Same step then is to solve. So this x here is going to be minus 5, and the other one becomes positive 5. And then you're at the same point. Okay, what's my inequality then? So I'm going to draw my really dodgy graph. Minus 5 and 5, draw a line because it's positive x squared. And then I'm saying, right, okay, this is the line. Is the part of the line that I want above or below the point where y is 0? Well, in this case, it's below, isn't it? 0 is greater than the line, so I'm referring to this point in the middle. Therefore, my inequality is -5 is less than x, which is less than +5. It's the range, isn't it? It's all of these values in the middle. That's literally it. We just need to be able to recognise difference of two squares in any context. Okay, this question is a mixture of the previous two. Okay, not only do we need to rearrange it, right, because we want to have everything on one side and a 0 on the other, but also you're going to see what format we create when we do that. So as I said, I want x squared to be positive, so I'm going to move the 81. We obviously have to subtract that from both sides. I haven't multiplied or divided by a negative number, so I don't need to flip my symbol, and obviously then that's 0. And then you see we've got the difference of two squares again. 81 is a square number, isn't it? So step 1, factorise. X plus 9, x minus 9. Simple as that. Solve. Okay, well, x is either going to be -9 or +9. And then put it in your inequality. So like I said, either you've got it memorised or you can do your little sketch. -9 and +9. Oh, completely missed that. Let's try that again. I mean, it doesn't even matter if you miss it, to be fair. So that's my graph, and I'm referring back to this one here, right? I need everything where I've got a 0 on one side. So where y is equal to 0 is this, obviously, this x-axis line here. Am I saying that my line, so the line is above or below where y is 0? In this case, it's facing towards the line, isn't it? So therefore, the part of the line that I want is above where y is 0. So I need the two tails. Therefore, my inequalities are the two separate ones, aren't they? So x is anything less than -9, and x is anything greater than +9. Double check. Okay, yes, I've got an equal sign, so I need to put that as well. And there we go. It's literally as simple as that, okay? Okay, we've basically gone through all of it. This one now, the only reason why it's different is because we've got 2x squared. Okay, so nothing to do with the inequality itself, just to do with factorising what we call harder quadratics, okay, where you've got a number or we've got a coefficient for x squared that's not 1. Okay, so again, if you feel like you're not sure about how to factorise these, check out the two videos we have. We've got two methods for doing factorising what we call harder quadratics. So I'm just going to whiz through it because obviously this video is not based on factorising. So step 1, we're going to factorise it. I'm going to use trial and error method again because these numbers are quite small. 2 is a prime number, 1 is obviously very easy to find the factors of. So because 2 is a prime number, I know it can only split into 2x and x. Then we're multiplying to make a negative. Okay, well, that means I need a plus and a minus, but I can't put them in yet because obviously, given that I've got 2x and x, they're different brackets. So I need to hold fire on that. So we need factors of 1 that add together to make -1. Obviously, one of them is going to be doubled, okay? So that's where you have to figure that out as well. This one's easy, obviously, because factors of 1 is 1 and 1. I can put that straight in because they're the same thing, okay? But then I need to figure out where my plus and my minus goes. Well, if I were to expand it, 2x times 1 is 2x, and 1 times x is 1x. How would I add these together? Which one would be plus and which one would be minus to get minus 1x overall? Well, the bigger one has to be the negative, doesn't it? -2x plus x is -1x, okay? So I need to put the minus here and the plus here. Okay, so I factorised that. Now we're on to solving. Now, the second bracket's easy to solve. We just flip the symbol. However, the first one, I'm just going to go into this again. It's not just -1, is it? So let's go back to where we said if the first bracket equals 0, we've got this linear equation. I would have to -1, just as before, but I would also then have to divide by 2, wouldn't I? So just be careful of that. I've got -1/2. Or if the other bracket equals 0, that one's just straightforward, isn't it? That's just 1. And now we're back to putting it into an inequality again. So I always use my graph. As I said, you don't have to though. You can just memorise the format. So positive x squared is a U shape. And I'm saying, okay, the line, is it above or below where y is 0? In this case, it's below, isn't it? It's below where y is 0. It's less than 0. So I need this bit. So therefore, my answer is going to be a range. X is somewhere between -1/2 and 1. Double check, yes, I have got my equals sign, so I need to copy the equals as well. So there's your answer. Okay, so it's no different. The only bit that's different is the factorising, isn't it? It's a bit harder to factorise and a bit harder to solve, but you should be happy with that anyway, separately to inequalities. Okay, feel free to pause the video, try this one out, because it's exactly the same thing. Obviously, again, it's just a harder quadratic to factorise. That's the only difference, okay? So give it a go, and now we're going to go through it. Step 1, factorise, okay? Well, 3x squared, 3 is a prime number, so that's easy. I know it's going to be 3x and x. Then my symbols, I'm multiplying to make a negative. So I know I need a plus and a minus, but again, I don't know which bracket's which yet. Then I need factors of 36 that when I add them, they get 3. Okay, they make 3. Obviously, one of the ones that you put here is going to be multiplied by 3 as well to help with that adding up. So factors of 36, obviously I would test it all out, but I'm just going to skip right ahead. I know that I've got 12 and 3. That would multiply to make 36. And if I multiply 3 by 3, I get 9, don't I? The difference then is 3. That's quite complicated because there's so many 3's there, but if you're not sure about factorising, as I said, just check out that video. Okay, this video is not the one to be going through explaining factorising. So I need 3 here and I need 12 here. That makes 36, but then when I do 3x times 3, I get 9x and then 12x. So I need to make positive 3 overall. So I'm going to have to add the 12 and minus this 3 because that becomes 9, doesn't it? Okay, so I know I've whizzed through that, but check out the video if you're not sure about how I've done that. Now I'm going to solve it. So I know that this side I'm going to have to minus 12 and then divide by 3, okay? So I know x is therefore minus 4, isn't it? 12 divided by 3 is minus 4. And the other side, or x is just 3. Okay, I've skipped obviously the writing there because that's not as important. And now the actual bit that we want is solving it. So I've got minus 4 and I've got positive 3. I know it's a positive quadratic, so I can just draw it like this. And I'm saying, okay, where y is equal to 0 is the x-axis, as we've said before. And I'm saying the line is what? In this case, greater than 0. So I'm saying I want the part of the line that is above y equals 0. So I want the two tails. Therefore, x has to be less than minus 4 and greater than 3. And there's not an equal sign, so I'm just leaving it as it is. Okay, that's your answer for that one. All right, so we've gone through basically everything on quadratic inequalities. I've got 2 more questions though, which are a little bit different because they could ask you, as maybe even a 5-mark question, to solve 2 inequalities. So here it says solve the following inequalities. X is greater than or equal to minus 3 and x squared plus 2x minus 8 is less than 0. So we've got one linear and one quadratic. What we need to do is basically find an inequality at the end that satisfies both of these inequalities. Now, as you can see, the linear one is already solved, isn't it? There's not anything in the way of the x. So we don't need to do anything with that one. That one, just leave that there for now. What we do need to do, though, is solve the quadratic one just as we did before. So if you want to pause the video and just solve that for now, feel free to do that. So I'm going to solve the quadratic one. Same exact steps we need to factorise. So I know it's going to be x and x. We're multiplying to make a negative. Okay, so that's going to be a plus and minus. I can put those in immediately because they're both x in each bracket. It's the same thing. So factors of 8, that when I add them together I get 2. Obviously the 1 plus and 1 minus. Oh, that's pretty obvious, 4 and 2. I need positive 4 and negative 2 because overall it's positive 2, isn't it, when I add them together? And solve it, okay, x is minus 4 or positive 2, and then get my actual inequality. So I'm going to whiz through this bit because obviously we've explained it a lot before. So it looks something like this, and I'm looking back, okay, I'm referring to the part of the line that is below 0, aren't I? Less than 0, so here. Therefore, my quadratic inequality is a range. It's between minus 4 and positive 2. There's no equals, so that's that. So I've solved that, okay? That's the first bit. Now, because like I said, our linear inequality is already solved, I would draw a number line again because I'm quite visual in that sense. You might be able to just see it in your head and go, I know where both of these overlap. I'm just going to draw a number line because that helps me, to be honest. So it doesn't, you're not going to get marks necessarily for the number line because it hasn't asked us to write it on there, but I'm just doing it for my own benefit, really. So you can just sketch it on the corner of your page. Okay, we've got that. Draw both of the inequalities on the number line, okay, like one on top of the other. You should have already seen the video on drawing inequalities on number lines, so this should be fine. Okay, so I'm going to do the linear one first in pink. So obviously draw a circle at minus 3. I'm going to colour it in as well. because it's equal to as well, isn't it? And then x is greater than that. It's open-ended, so I'm just drawing an arrow to the end of my number line. And let's say if we do my quadratic one in this blue colour, okay, a circle at -4 and at 2, it's a range, so I just need to join them up, don't I? And they're not coloured in because they're not equal to. Okay, so you've got that. You just need to see where both of them overlap. That's literally it. The inequality we want that satisfies both of these is where they overlap. I'll make it really clear with my highlighter. Can you see that -4 only satisfies the quadratic one, the top one, doesn't it? It doesn't satisfy this pink one here, does it? So what I'm saying is this part up to 2 works. Now technically the pink one does go on, longer, but obviously our quadratic one stops at 2, okay? So do you see how the yellow bit is where they both overlap? So my actual final answer, which I'll write here, final answer has to be, the smallest it is -3, isn't it? Which is also equal to, okay? Because it could be equal to for the blue one as well. And x, and then up to 2, but not equal to 2. This is my final answer. Okay, so you don't have to draw the number line, as I said. You might just find it helpful to visualize it. If you can see it in your head, or you can just look at the numbers and figure it out, then great, just do that. But the whole point is deal with both of the inequalities separately if you need to solve them. Obviously, we had to just solve the quadratic one. The linear one was already fine, wasn't it? Then put them on a number line if that helps to visualize where they both overlap. Okay, this is exactly the same question, literally the same thing. You can see we've got solve the following inequalities. X squared minus 10x plus 21 is less than or equal to 0, and x is less than 5. Okay, so one linear, one quadratic. Pause the video if you want to have a go at this one yourself. Just do exactly what we did in the previous video, and we'll go through it. So as you can see again, we've got the linear one, which is already fine. We don't need to solve that, do we? That's already x is less than 5. Don't need to do anything there. We do need to solve the quadratic one, so factorise it. So I've got x and x. My symbols, we are multiplying to make a positive, but when I add them, it's negative. I need 2 negatives. And then we need factors of 21 that would add together to make 10. So 7 and 3 would work, wouldn't it? Okay, then we want to solve it. So I've got x is 7 or 3. And finally, as my inequality first, I like to use my graph, but as I said, you don't have to do this. 7 and 3, it's a positive, so I know it's like this U shape. Okay, let's look back at the inequality. Is my line, the part of my line is less than 0, isn't it? Less than where y is equal to 0. So again, I'm looking for this range. Okay, so to solve my quadratic inequality, I have 3 and then 7. X is in between them, and it's also equal to, isn't it? Because that's what I have here. Okay, I've solved that really quickly. As I said, the linear one's already solved. Now I'm just going to get out my number line. As I said, you might want to do this to help. You don't have to, but I would like to do it just to visualize. So 3, 4, 5, 6, 7, 8. That's fine. Okay, draw both of them on. So my linear one, x is less than 5, isn't it? So circle at 5, not coloured in, and anything less than that. And then my quadratic one, we've got circles at 3 and 7, and they are equal to, so I need to colour them in, and then draw a line between them. Now all we need to do is see where do both of these overlap. If I get my highlighter, you can see it's quite a narrow range actually, isn't it? From 3 up until 5. That's where they overlap, isn't it? My final answer, the smallest value it can be is 3, isn't it? And it can be also equal to that, so 3 is less than or equal to x, and the biggest value is 5, but it can't be equal to that, can it? So do you see that's where it overlaps? X is somewhere between 3 and 5. If it's an integer, which is a whole number, it's basically either 3 or 4, isn't it? It can't be 5. Okay, that's your final answer. So that is everything now on inequalities. If you've seen the other 3 previous videos, then you've gone through everything you need to know. As you can see here, the final 2 videos, so inequality regions and the one we've just done, is higher tier only. If you're doing higher tier, you need all 4 of these videos, okay, not just the last 2. If you're doing foundation tier, which hopefully you won't have seen this video anyway, you only needed the first 2 videos, okay, so ignore this video and the previous one. If you've got any questions, please leave them down below in the comments, and then feel free to check out anything on factorising if you want to go back and brush up on those skills.